Hi everybody. So several of you have asked me to go over question 8 on the week 6 homework, and even if you've turned it in, it's not a bad idea to go through this so that if you get a question like this on the exam, lecture exam 2, which is coming out this weekend, you'll be more familiar with it. So question 8 on the homework was you were given this equation, right? Propane, C3H8 in gaseous form, plus 5 molecules of gaseous oxygen, yielding 3 molecules of gaseous carbon dioxide plus 4 molecules of water vapor or gaseous water. Okay, this is the combustion reaction of propane, right? Combustion involves oxygen and the fuel itself, the propane. And what we were told was that the heat of reaction for the combustion of propane, so for this reaction, right, is negative 2,045 kilojoules. The equation for determining the heat of a reaction is the delta change in the heat of a reaction, right? That delta means change. So the change in the heat of the reaction is equal to the sum of the changes in the heats of formation of the products, right? These guys to the right of the arrow, minus the sum of the products of the heats of formation of the reactants, these guys here. So how do we find, the first thing is how do we find the heats of formation of the products and the reactants? There was a table that came along with the homework. And if I can pull it up here, okay, there is the table right there. So that should be in your homework. Okay, and I'm just showing you, some of you I actually just sent the answer key, but I want to go through it in more detail. So what we know here too is I just put a little note. If the heat of combustion is negative, so minus 2,045 kilojoules, then this means that the reaction is exothermic, or that it's giving off energy or losing heat to the environment. So what do we know? We know the heat of the reaction because it was given to us in the problem, minus 2,045 kilojoules. And we also know the heats of formation in kilojoules per mole for oxygen, for CO2, and for water from the table. Okay, so, and I know one of the issues before was that it was too compressed on the page. So what I did was I filled this out. Now, one thing you have to keep in mind is any of the coefficients, right, that were existing in the previous equation, you have to carry over here. So there were 3 molecules of carbon dioxide. So we're going to multiply the heat of formation of carbon dioxide from the table, which is negative 394 kilojoules per mole, by 3. And this coefficient actually means 3 moles of carbon dioxide, right? We know from molecular formulas. So that's going to be plus 4 times water, because that's in the original equation. You might say, but wait, those were to the right of the arrow in the original equation, right? And this guy right here, yes, these are your products. So that's why we do the products first, right? That's the equation. So it's 3 times negative 394, the moles cancel out, plus 4 times negative 242, the heat of formation for water. That gives us this. And it's these minus the difference in the reactants, right? So there's only 1 mole of propane, the C3H8, which has a heat of formation that we want to calculate, right? That's what we don't know. Excuse me. And then we have 5 molecules of oxygen. And the heat of formation of oxygen is actually 0. So when we do this, right, we have the products here, negative 1,182 plus negative 968, which gives negative 2,150 kilojoules, minus 1 mole times the heat of formation of propane plus 0. So that just gets down to the heat of formation of propane. How do we get this alone? Well, we can add 2,150 to each side. If we do that, then we have the heat of the reaction, right? Negative 2,045 plus 2,150 gives us 105 kilojoules, but we are left with the negative heat of formation, of propane down here. If we multiply this by negative 1, we'll make this a positive. We'll do the same to this side. So the heat of formation, I've got the F again, okay, of propane is equal to minus 105 kilojoules.